interfaces, then everyone has to write code at machine language. And maybe if that is the situation, very few perhaps are capable of working with computers. With the advent of compilers and all, now everyone is able to write a code in high level language, and the rest is taken care by the compiler and OS, so that it is translated to the machine language and then it is executed by the OS. This is what happened. Whereas in the distributed system, the person, he has to write the code at the low level and then only he gets implemented. So that expertise is very difficult. Very few have been getting benefited out of distributed systems. That's why this big data framework has come up. The first version of Hadoop released, and thus now we can give high-level program to Hadoop so that it implements our code and gives us. Hope we have studied in the curriculum, when the Hadoop is designed, there were issues that who should dictate the distribution of the data. Then they cleverly thought that distribution of data depends upon the availability of the memory and knowledge about the commodity systems which are beneath the Hadoop in the framework. Though you know it, you cannot dictate the proper distribution. That's why people thought that distribution should be in the hands of Hadoop. That's why we generally say, you give data, Hadoop distributes as it likes. But the challenge is, you have to write a code so that it works whatever the way Hadoop distributes the data. That's the challenge. And Hadoop people, they have considered the MapReduce computing paradigm. That's what they understood. The moment I give data and you have distributed it, hence each system has got only one part of data. It is not having access to the entire data. Therefore, whatever the algorithm you run in that particular system, it can find only the local knowledge hidden in that part of the data. Similarly, even if you run the same algorithm in all the systems where different parts of the data are being present, then these systems individually they can give the local knowledge present in each pieces of the data. Now the issue is, how do we combine this local knowledge to obtain a global knowledge? That is what we do it at the reduced level. This is how people have identified. This is the fundamental issue that they have looked at. The moment you distribute the data, this is the issue which is to be addressed. Hence, they have addressed it that way. They considered by the time already we have reduced computing paradigm over there. They have implemented it. This generally, the students are not exposed to big data analytics or the distributed systems. They are not knowing, because most of the algorithms which we have seen are written with one assumption that algorithm has access to entire data. This is unwritten assumption. Whenever you write an algorithm, you will assume that algorithm will come in a system where it has access to entire data. But whereas just now I described, you cannot keep data in a single system. Why? It is called big data. Big data means data is big to a system. You cannot store it in a single system. You must distribute. Thus, it became inevitable for the people. If you want to process the big data, go to Hadoop and give it, write MapReduce code, and let it be implemented in Hadoop and correct it. And of course, some of you have undergone the course, how Hadoop distributes and how MapReduce works. what needs map logic, reduce logic, input and output. And particularly these MR codes, they take key value pairs and produce key value pairs. It is very restricted kind of environment where you cannot write any number of programs to implement your job. You have to write map and reduce only two. And each one again, it takes a key value and emits a key value. Hence you cannot take any number of input parameters and produce any number of output parameters. Hence in such a constrained environment people have to work it. That's how our journey has started. And of course now people are getting a little bit relaxations. And side by side people have looked at, there are so many other things have to be developed in the ecosystem. Hence other things such as NoSQL databases which are supporting these big data have also been emerged in due course of time. And people should remember that NoSQL means we are not saying goodbye to SQL. NoSQL means not only SQL. You know, if you cannot understand non-vegetarian, any non-vegetarian is there here? Non-vegetarian means, will they take vegetarian or not take vegetarian? Non-vegetarian means not only vegetarian. Non-vegetarian means not only vegetarian, means they take something else also. That's why NoSQL means, don't say that not SQL. It is not only SQL. That is the point. Hence here they don't want to deal in the SQL way. That's how there are so many things which are very much interested to the young generation. I appeal to the young generation that the future is only this big data framework and all other things. Because you cannot imagine the system which will handle the large amount of data that is emerging from the web. Hence we have to master this distributed approaches, big data approaches. And don't think that anyway I don't like this data mining, data engineering, big data analytics. I will study IoT. No, IoT is also basically ultimately finally joins with big data. The IoT is basically inherently it is a distributed network. Hence the data is emerging from various sensors. Hence if you do not have distributed approach, you cannot really work with the IoT. If you do not have distributed approach, what will happen? You have to collect the data from various sensors to a centralized repository. Some decision has to be taken at the centralized repository, and then again the decision should go to the respective edges. Then only something can be done. Instead of bringing everything to centralized repository, better you keep from the respective places. Cancel it as a Hadoop kind of thing, something which you can put it, a big data framework, you can put it, and then thereby you can analyze it. Hence now it is high time to, from every domain, you have to tune your earlier algorithms which will work with this kind of big data framework. Because those earlier algorithms were written with whatever the assumption I said, that those algorithms are assuming that they need access to entire data, and those algorithms won't work. For just to the third year, second year students, you know, this algorithm which finds the shortest path from source to various destinations. You don't know. Hence, this algorithm we run it on a system where we load a graph. Is it a graph containing nodes and edges? Nodes are representing, say, cities, and edges are representing maybe distance or cost traveling. Then you have to find the shortest path. Hence, I will load India graph, and then I will ask you come and find the shortest path from Warangal to Delhi. this algorithm is finding. Hence it is working fine. But now what happened? The graph is so big, you cannot load the entire graph in a system. Then what you will do? You have to give this graph to the, say, Hadoop, then it will distribute. And now suppose it is distributed to 10 people, then each one is holding different parts of India. Hence, even if you copy this algorithm 10 copies and run on these things, where each person is holding only one part of this India graph. And if you run this algorithm here, if I give the query, what is shortest path from Warangal to Delhi, then you will say Warangal is there, sir, but Delhi is not there. The other one who is holding Maharashtra will say Warangal is not there, Delhi is also not there. Therefore, now Distra will it work? No. Therefore, prior to Distra, the problem was unsolved. Now, in the current scenario where the big graphs, where graphs cannot be loaded in a single system, or graphs are already distributed, inherently distributed because of your memory or something, then your earlier algorithms won't work. That's why now it is a great opportunity to all the people who, whatever the area you are working, image processing, networks, whatever, you consider some algorithm, understand it well. You come on, think of what will be the equivalent algorithm in the distributed environment. More particularly, you can run on this kind of Hadoop and all, and then you can switch to other ecosystems. Hence, this you consider it thereby. And now I will be. Hence, this is another problem. Perhaps some of you who have studied data mining know that frequent patterns. There are many problems, from 4 to 5 problems which we have considered, but I may explain one problem. That is frequent item set mining. That will be the first problem. Then further sequential patterns, high-intensity patterns. There are many other problems from data mining tuned to big data. These are all what I have already said. Now, since you know the frequent item sets, item set means set of items. Frequent means if you take a typical example that the items are the items in a supermarket, and I want to find what are the different items purchased together more frequently by the customers in a supermarket. Then we can make use of the celebrated upright algorithm, you know it, data mining. That is one of the very elementary algorithms which people use to find frequent item sets. I said the definition of frequent item set. The item sets which are purchased frequently together. Hence, this frequently is one issue. Together, then we will come to know that okay, these 10 items, suppose those 10 items are purchased together frequently, you have to keep those 10 items at one place. Hence, this can be used to recommend how to keep the items on the shelves. Or you can keep 6 items here and you can mark it, the remaining 4 items at the end of this, so that they will expose to other items in between and then so on. Like that, right from late 80s, it has been used in several directions. But all those algorithms were written with the earlier assumption, and now recently there is one FIDU is there, that is frequent item set using Hadoop like that. They have designed some algorithm which will work on Hadoop, map reduce kind, which we took it and we have improved it. That's and here, these are the few issues which we have addressed as far as this first problem is concerned. We want to represent it in a compact way. That's why we introduced some big vector data structure, and then we designed a parallel compression algorithm defining certain operations on big vectors. And we make use of this, and then we design map MR code so that we get this. This is the explanation that we have certain number of transactions